Which of the following statements accurately describes the purpose and functionality of A? Selector Mixin class in scikit-learn? A. Selector Mixin provides a framework for feature selection techniques in scikit-learn, enabling the implementation of custom feature selection strategies. B. Selector Mixin is used to evaluate the performance of feature selection methods, providing metrics to assess the effectiveness of different techniques. C. Selector Mixin is responsible for selecting the optimal features from a dataset, automating the feature selection process based on predefined criteria. D. All of the above. Correct. The Selector Mixin class provides a foundation for building custom feature selection algorithms in scikit-learn, enabling the implementation of diverse strategies for feature selection. Correct. The Selector Mixin class integrates with various metrics and scoring functions to evaluate the effectiveness of feature selection methods, aiding in assessing the performance of different selection strategies. Correct. While Selector Mixin helps in feature selection, it does not automatically select the optimal features. It provides the framework for implementing feature selection algorithms, but the selection itself depends on the algorithm used. Correct. All the statements A, B, and C accurately describe the purpose and functionality of the Selector Mixin class in scikit-learn. D. All of the above. Feature selection. The process of selecting a subset of relevant features from a dataset for use in machine learning models, aiming to improve model performance, reduce overfitting, and simplify the model. Feature engineering. The process of transforming raw data into meaningful features that can be used to train machine learning models, including feature selection, creation, and transformation. Model evaluation. The process of assessing the performance of a machine learning model using various metrics and techniques to understand its accuracy, generalization ability, and other characteristics. Overfitting. A phenomenon where a machine learning model performs well on the training data but poorly on unseen data, indicating that the model has learned the training data too well, including noise and irrelevant patterns. Underfitting. A phenomenon where a machine learning model fails to capture the underlying patterns in the data, resulting in poor performance on both training and unseen data, indicating that the model is too simple. Dimensionality reduction. A technique used to reduce the number of features in a dataset by transforming the data into a lower dimensional space while preserving as much information as possible. Often used to improve model performance and reduce computational complexity. Use cases. Real-world applications where feature selection techniques are crucial for improving model accuracy, efficiency, and interpretability. What does the Selector Mixin class in sklearn features election do? And why is it useful for feature selection? Provides methods for selecting features based on their statistical significance or relevance. It helps remove redundant or irrelevant features from a dataset. Simplifies model building by reducing the number of features. All of the above. True. The Selector Mixin class is a base class for feature selection methods. It provides methods like fit to learn from the data, transform to select features, and fit transform to perform both tasks. These methods are used to select features based on statistical significance or relevance. Aligning with this option. Feature selection. True. By selecting features based on their statistical significance or relevance, the Selector Mixin class effectively helps in removing redundant or irrelevant features from a dataset. This reduces the dimensionality of the data, which is often beneficial for model building. Dimensionality reduction. True. By removing redundant or irrelevant features, The selector mixin class significantly reduces the number of features in a dataset. This simplification makes model building faster, more efficient, and less prone to overfitting. This directly relates to the concept of simplifying model building. Model evaluation. True. The explanations for options A, B, and C all accurately describe the functionality and benefits of the selector mixin class. Therefore, the correct answer is all of the above. Feature selection. D. All of the above. Feature importance. Feature importance refers to the degree to which a particular feature contributes to the prediction of a model. Feature selection techniques often leverage feature importance to identify and prioritize features. In a marketing campaign, feature importance analysis might reveal that age, income, and purchase history are the most influential factors in predicting customer response to a new product. This information helps refine targeting strategies for maximum impact. Filter methods. Filter methods are feature selection techniques that use statistical measures like correlation, variance, or mutual information to assess the relevance of features without involving a machine learning model. In a fraud detection system, a filter method could be used to select features that exhibit high correlations with fraudulent transactions. This pre-screening can help focus the model's attention on suspicious activities. Wrapper methods. Wrapper methods evaluate the performance of a model by iteratively adding or removing features and assessing the resulting model's accuracy. These methods typically require more computational resources than filter methods. In a medical diagnosis system, a wrapper method might involve training a model with different combinations of medical features, evaluating the model's accuracy in diagnosing specific diseases, and selecting the feature set that produces the best diagnostic performance. Embedded methods. Embedded methods incorporate feature selection as part of the model training process. These methods often learn feature importance during the model fitting process and use this information to select the most relevant features. In a customer churn prediction system, an embedded method might utilize a regularized linear model like Lasso that automatically selects features during training based on their impact on minimizing the prediction error. This process simultaneously fits the model and selects the most informative features. Dimensionality reduction. Dimensionality reduction techniques aim to reduce the number of features in a dataset while preserving as much information as possible. This can be achieved by transforming features into lower dimensional representations or by selecting a subset of the most relevant features. In image recognition, dimensionality reduction techniques like principal component analysis (PCA) can be applied to reduce the number of pixels in an image without compromising its essential features. This can significantly reduce the computational cost of processing images. Model evaluation. Model evaluation involves assessing the performance of a machine learning model on unseen data. This helps determine the model's generalization ability and identify potential weaknesses or areas for improvement. In a loan approval system, model evaluation techniques are used to assess the model's accuracy in predicting loan defaults. This helps ensure that the model is reliable and does not approve loans to individuals who are likely to default. Overfitting. Overfitting occurs when a model learns the training data too well, leading to poor performance on unseen data. This happens when the model becomes overly complex and captures noise in the training data. In a stock market prediction model, overfitting can occur if the model learns the specific patterns in historical stock prices but fails to generalize to future price movements. This can result in inaccurate predictions and financial losses. Model interpretability. Model interpretability refers to the ability to understand how a model makes predictions. It is important for trust, transparency, and explainability, especially in applications where decisions have significant consequences. In a medical diagnosis system, model interpretability is crucial for understanding why a model diagnoses a patient with a particular disease. This allows doctors to validate the model's decision and trust its predictions. Which of the following statements is true about using the chi-squared test for feature selection in scikit-learn sklearn? A. It can only be used for categorical features. B. It measures the dependence between categorical features and the target variable. C. It calculates a p-value for each feature, indicating the probability of observing such a strong association by chance if there were no true association. D. All of the above. The chi-squared test is primarily used for categorical features. It analyzes the relationship between these features and the target variable, which is also expected to be categorical. True. The chi-squared test measures the dependence between categorical features and the target variable by examining the observed frequencies against the expected frequencies under the assumption of independence. True. The chi-squared test calculates a p-value for each feature. This p-value represents the probability of observing the observed association purely by chance. Assuming there is no true association between the feature and the target variable, a lower p-value suggests a stronger association and indicates that the feature is more likely to be relevant for predicting the target. True. All the above statements are true. The chi-squared test is specifically designed for categorical features, measures the dependence between these features and the target variable, and calculates p-values to quantify the association strength. In sklearn, the select k-best class with the chi2 scoring function implements this test for feature selection. True. D. Feature selection is the process of identifying and selecting the most relevant features from a dataset to be used in machine learning models. It helps improve model performance, reduce overfitting, and simplify the model. In a customer churn prediction model, selecting relevant customer demographics, usage patterns, and engagement metrics can significantly improve the model's accuracy. For image classification, selecting the most informative image features can reduce computational costs and improve classification accuracy. In fraud detection, identifying features that are most indicative of fraudulent transactions can help improve effectiveness of fraud detection models. In a medical diagnosis model, selecting relevant medical history, symptoms, and test results can lead to more accurate diagnosis. Consider a dataset with 10 features. Feature selection aims to identify the subset of features that are most predictive of the target variable. For example, if the target variable is customer churn, we might identify features like average monthly spending, contract length, and recent customer support interactions as being most predictive. The chi-squared test is a statistical test that measures the association between two categorical variables. In the context of feature selection, it assesses how strongly a categorical feature is associated with the target variable. Analyzing the relationship between customer age and their purchase preferences in a retail setting. Determining if there is a significant association between gender and product reviews. Investigating the relationship between different advertising channels and customer conversions. Exploring the association between patient demographics and their disease susceptibility. Suppose we have a dataset of customers with features like age group categorical and purchase frequency categorical. We want to determine if there is a statistically significant association between these features. The chi-squared test helps us calculate the p-value, which indicates the likelihood of observing the observed association by chance if there is no true association between the features. In the chi-squared test, the p-value represents the probability of observing the observed association by chance. Assuming there is no true association between the feature and the target variable, a low p-value indicates a strong association. In a medical study, the p-value helps determine the significance of a drug's effectiveness compared to a placebo. In market research, the p-value can indicate the significance of a new product's performance compared to existing products. In social science research, the p-value helps assess the significance of observed correlations or relationships between variables. In environmental studies, the p-value can help determine the significance of the impact of a particular factor on the environment. Imagine we want to determine if there's a relationship between a new marketing campaign and increased sales. We calculate a p-value from the data. If the p-value is 0.05, it means there's a 5 chance of observing the increase in sales by chance even if the marketing campaign had no real effect. A lower p-value, like 0.01, would indicate a stronger association and suggest that the marketing campaign is more likely to be contributing to the increase in sales. Select K-Best is a feature selection method provided by sklearn that allows you to choose the K-Best features based on a scoring function. The chi2 scoring function uses the chi-squared test to assess feature relevance. Using select K-Best with the chi2 scoring function to select the top 5 most informative features for a customer churn prediction model. Employing select K-Best with the chi2 scoring function to identify the most significant image features for an image classification task. Utilizing select K-Best with the chi2 scoring function to determine the most relevant features for a fraud detection model. Applying select K-Best with the chi2 scoring function to select the most informative features for a medical diagnosis model. Suppose we have a dataset with 20 features and want to reduce it to 10 features. We can use select K-Best with the chi2 scoring function to identify the 10 features that have a strongest association with the target variable, based on the p-values calculated by the chi-squared test. Which of the following statements accurately describes the sklearn features election? F-classif function. A. It calculates the F statistic for each feature, assessing its relevance to the target variable in a classification problem. B. It applies a one-way ANOVA analysis of variance test to evaluate the relationship between features and the target variable. C. It uses a chi-squared test to measure the association between categorical features and the target variable. D. All of the above. Correct. The F-classif function calculates the F statistic for each feature. The F statistic measures the ratio of the variance explained by the feature to the residual variance. A higher F statistic indicates a stronger relationship between the feature and the target variable, suggesting greater relevance. F statistic. Correct. F-classif internally uses a one-way ANOVA test to assess the relationship between each feature and the target variable. ANOVA analyzes the variance within and between groups defined by different categories of the target variable. If there are statistically significant differences in the variances, it indicates a relationship between the feature and the target. ANOVA analysis of variance. Correct. F-classif utilizes a chi-squared test for evaluating the association between categorical features and the target variable. It compares the observed frequencies of the feature categories with the expected frequencies based on the target variable. A significant chi-squared statistic suggests a dependence between the feature and the target. Chi-squared test. Correct. All the statements A, B, and C are correct descriptions of the F-classif function. F-classif. D. All of the above. In text classification, F-classif can help identify important words or phrases that contribute to categorizing documents. For instance, in spam detection, F-classif could identify words frequently associated with spam messages. Identifying spam emails by selecting features like the presence of specific words or phrases often found in spam emails. Suppose we have a dataset of emails with features like word count, number of exclamation marks, and presence of specific words and the target variable being spam1 or not spam0. F-classif could help us select the most relevant features for distinguishing spam emails. In image recognition, F-classif can help select important features from images like pixel values or pre-extracted features. This helps in identifying objects or recognizing faces in images. Identifying different types of animals in images by selecting relevant image features like color, texture, and shape. Consider an image dataset of different animals with features like average color, texture complexity, and shape features. F-classif could help select the most informative features for classifying the animal type. F-classif can aid in selecting medical parameters or symptoms that are most relevant for diagnosing diseases. This can improve the accuracy and efficiency of diagnostic models. Identifying patients with a specific disease based on features like blood sugar levels, blood pressure, and age. Imagine a dataset of patients with features like blood pressure, cholesterol level, and age and a target variable indicating whether they have a specific disease. F-classif can help identify the most relevant features for disease prediction. Feature selection. F-statistic. ANOVA analysis of variance. Chi-squared test. Classification problem. sklearn. Feature selection. Which of the following best describes the purpose of the regression function in scikit-learn's feature selection module? A. To identify features that are most correlated with the target variable, regardless of whether the relationship is linear or nonlinear. B. To rank features based on their ability to explain variance in the target variable, considering both linear and nonlinear relationships. C. To identify features with the strongest linear relationship with the target variable, using an F-statistic. D. To select features that minimize the mean squared error of the regression model. False. While regression aims to identify relevant features, it specifically focuses on linear relationships and doesn't account for nonlinear correlations. C. LT font style quote font size 14px quotient to identify features with the strongest linear relationship with the target variable, using an F-statistic. LT font GT. False. Regression primarily focuses on linear relationships and uses the F-statistic to rank features based on their linear correlation with the target. It doesn't directly consider nonlinear relationships. C. LT font style quote font size 14px quotient to identify features with the strongest linear relationship with the target variable, using an F-statistic. LT font GT. True. Regression uses the F-statistic to assess the linear relationship between each feature and a target variable. Features with higher F-statistics indicate stronger linear correlations. C. LT font style quote font size 14px quotient to identify features with the strongest linear relationship with The target variable, using an F statistic, LT font GT. False. Regression doesn't directly optimize for minimizing mean squared error. Its purpose is to rank features based on their linear correlation with the target variable, which can then be used to select features for a regression model. C. LT font style quote font size 14px quotient to identify features with the strongest linear relationship with the target variable, using an F statistic, LT font GT. C. The process of selecting a subset of relevant features from a dataset for use in a machine learning model. Reducing dimensionality of high-dimensional datasets to improve model performance. Identifying the most influential factors in a business problem. Simplifying a model for easier interpretation. A statistical measure that assesses the variance explained by a feature in relation to the residual variance. A higher F statistic suggests a stronger linear relationship. Evaluating the significance of independent variables in a linear regression model. Comparing the effectiveness of different features in explaining the target variable. Identifying features that significantly contribute to the overall model variance. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. The F statistic is calculated by dividing the variance explained by the feature by the residual variance. A high F statistic indicates that the feature explains a significant portion of the variance in a dependent variable, suggesting a strong linear relationship. A statistical method that models the linear relationship between a dependent variable and one or more independent variables. Predicting house prices based on factors like size and location. Estimating sales revenue based on marketing spend and seasonality. Analyzing the relationship between income and education levels. A popular Python library for machine learning that offers various tools for feature selection, model training, and evaluation. Building and training machine learning models for various tasks like classification, regression, and clustering. Preprocessing data for machine learning algorithms. Evaluating the performance of different models using various metrics. A function in scikit-learn's feature selection module that calculates the F statistic for each feature and provides a ranking based on their linear correlation with the target variable. Selecting the most relevant features for a linear regression model. Reducing the dimensionality of data before training a complex machine learning model. Identifying features that are most predictive of the target variable in a regression setting. You are building a linear regression model for predicting house prices using features like area, bedrooms, bathrooms, and location. Which feature selection technique based on R² would you consider for identifying the most impactful features? Recursive feature elimination RFE. Select k-best with regression. Select from model with linear regression using R2 scoring. All of the above. True. RFE works by repeatedly constructing a model and then eliminating the weakest feature, the one with the lowest feature importance score. This process is repeated until a desired number of features is reached. It can use R² to assess the model's performance at each iteration. RFE works by repeatedly constructing a model and then eliminating the weakest feature, the one with the lowest feature importance score. This process is repeated until a desired number of features is reached. It can use R² to assess the model's performance at each iteration. True. Select k-best with regression utilizes a statistical test F statistic to rank features based on their correlation with the target variable. It selects the top k features with the highest F scores. R² can be used to evaluate the performance of the model with different numbers of selected features. Select K-best with regression utilizes a statistical test F-statistic to rank features based on their correlation with the target variable. It selects the top K features with the highest F scores. R-squared can be used to evaluate the performance of the model with different numbers of selected features. True. Select from model uses a pre-trained model. In this case, a linear regression model. It uses the model's coefficients or feature importance scores to identify significant features. The R2 scoring metric explicitly evaluates the model's performance based on R-squared, enabling feature selection based on how well the model explains the variance in the target variable. Select from model uses a pre-trained model. In this case, a linear regression model. It uses the model's coefficients or feature importance scores to identify significant features. The R2 scoring metric explicitly evaluates the model's performance based on R-squared, enabling feature selection based on how well the model explains the variance in the target variable. True. The correct answer is D. All of the above. The correct answer is D. All of the above. D. All of the above. Feature selection. The process of selecting relevant features from a dataset to improve model performance. The process of selecting relevant features from a dataset to improve model performance. R-squared coefficient of determination. A statistical measure that represents the proportion of variance in the dependent variable that is explained by the independent variables in a regression model. A statistical measure that represents the proportion of variance in the dependent variable that is explained by the independent variables in a regression model. sklearn, features election. A module in scikit-learn that provides various feature selection methods. A module in scikit-learn that provides various feature selection methods. Linear regression. A linear model in scikit-learn that uses ordinary least squares to fit a linear relationship between features and the target variable. A linear model in scikit-learn that uses ordinary least squares to fit a linear relationship between features and the target variable. Recursive feature elimination RFE. A feature selection method that works by repeatedly constructing a model and eliminating the weakest feature, the one with the lowest feature importance score. It can use R-squared to assess the model's performance at each iteration. A feature selection method that works by repeatedly constructing a model and eliminating the weakest feature, the one with the lowest feature importance score. It can use R-squared to assess the model's performance at each iteration. Select K-best. A feature selection method that selects the top K features based on a scoring function. A feature selection method that selects the top K features based on a scoring function. Regression. A statistical test F-statistic used to assess the correlation between features and the target variable in linear regression. A statistical test F-statistic used to assess the correlation between features and the target variable in linear regression. Select from model. A feature selection method that uses a pre-trained model to identify important features. A feature selection method that uses a pre-trained model to identify important features. These techniques are invaluable in real-world scenarios where we have a large number of features and need to identify the most relevant ones for building accurate and efficient machine learning models. For example, in predicting customer churn, we might have hundreds of customer attributes. Using feature selection with R-squared can help us identify the key drivers of churn and improve our model's accuracy. These techniques are invaluable in real-world scenarios where we have a large number of features and need to identify the most relevant ones for building accurate and efficient machine learning models. For example, in predicting customer churn, We might have hundreds of customer attributes. Using feature selection with R² can help us identify the key drivers of churn and improve our model's accuracy. Let's assume we have a dataset with 5 features x1, x2, x3, x4, x5 and a target variable y. We build a linear regression model with all features and obtain an R² of 0.75. Then, using RFE, we eliminate x5 and retrain the model, getting an R² of 0.77. This indicates that x5 was not a significant feature. We continue this process, eliminating features one by one, evaluating R² at each step to identify the most impactful features. RFE works by repeatedly constructing a model and then eliminating the weakest feature, the one with the lowest feature importance score. This process is repeated until a desired number of features is reached. It can use R² to assess the model's performance at each iteration. Question: which of the following statements accurately describes the role of mutual info classif in scikit-learn's feature selection process? A. It calculates the mutual information between each feature and the target variable, ranking features based on their predictive power. B. It removes features with low variance, aiming to reduce noise and improve model performance. C. It selects features based on their correlation with other features, identifying redundant variables. D. It applies a recursive feature elimination algorithm, iteratively removing features with the least impact on model performance. This statement accurately describes the role of mutual info classif. It calculates the mutual information between each feature and the target variable, providing a measure of how much information each feature provides about the target. Features with higher mutual information scores are considered more informative and are ranked accordingly. This helps in selecting features that have a stronger relationship with the target, improving model accuracy. True. Mutual information. This statement describes the role of variance threshold feature selection, not mutual info classif. Variance threshold removes features with low variance, aiming to reduce noise and improve model performance. False. Feature selection. This statement describes feature selection methods like correlation-based feature selection, which identify and remove redundant features based on their correlation with other features. However, mutual info classif focuses on the relationship between individual features and the target variable, not their correlation with other features. False. Feature selection. This statement describes the role of recursive feature elimination RFE algorithm. It iteratively removes features with the least impact on model performance, selecting features that contribute significantly to model accuracy. Mutual info classif doesn't directly employ RFE, but can be used in conjunction with it to identify the most informative features. False. Feature selection. A statistical measure that quantifies the dependence between two random variables. In the context of feature selection, it determines how much information a feature provides about the target variable. Features with higher mutual information scores are considered more informative. In medical diagnosis, mutual information can be used to identify key feature symptoms, test results that strongly predict the presence of a specific disease. For example, a high mutual information between fever and flu suggests that fever is a good indicator of influenza. Let's say we have two variables: temperature feature and health status target variable. The mutual information between these variables would measure how much information the temperature provides about the health status. For example, if higher temperatures are strongly associated with being sick, then the mutual information would be high. The process of selecting a subset of relevant features from a larger set of features. The goal is to improve model performance by reducing the complexity of the data and focusing on features that contribute the most to the prediction. Feature selection can be done based on different criteria like mutual information, correlation, variance, or feature importance scores. In image recognition, feature selection can be used to identify the most important pixels or regions of an image that contribute to the classification of different objects. By selecting relevant features, the model can become more efficient and robust. Consider a dataset with 10 features x1, x2, x10 and a target variable y. Through feature selection, we aim to identify the subset of features that are most relevant for predicting y. For example, we might find that features x1, x3, and x8 are the most informative and remove the rest. A function in sklearn that calculates the mutual information between features and the target variable for classification tasks. It returns an array of mutual information scores, one for each feature. In customer churn prediction, mutual info classif can be used to identify the most important customer attributes that influence churn behavior. This helps in targeting specific customer segments with appropriate interventions. Assume we have a dataset with features like age, income, purchase history, and customer loyalty and a target variable churn whether a customer left or not. Mutual info classif would calculate the mutual information between each feature and churn, revealing features like customer loyalty or purchase history that have strong predictive power for churn. What does mutual information regression MER aim to quantify in feature selection? A. The strength of the linear relationship between features and the target variable. B. The mutual information between features and the target variable, regardless of linearity. C. The variance explained by each feature in the target variable. D. The correlation coefficient between features and the target variable. False. MER quantifies the mutual information between features and the target variable, which encompasses both linear and nonlinear relationships. This choice focuses solely on linear relationships, making it incorrect. True. This is the core principle of MER. It measures the dependency between features and the target variable, regardless of whether the relationship is linear or nonlinear. This allows MER to identify features that may have a complex relationship with the target but still contribute significantly to its prediction. False. This describes the concept of R² in linear regression, which quantifies the proportion of variance in the target variable explained by the features. MER is not directly related to variance explained. While there might be a correlation between mutual information and variance explained, MER focuses on the dependency between variables rather than the amount of variance explained. False. Correlation measures the linear relationship between variables. MER is more general and can capture nonlinear relationships, making correlation a limited measure for MER. B. The mutual information between features and the target variable, regardless of linearity, measures the dependency between two variables, regardless of whether the relationship is linear or nonlinear. Image classification identifying relevant pixels or features for object recognition. Text analysis selecting keywords or phrases for sentiment analysis or topic modeling. The process of selecting the most relevant features from a dataset for a machine learning model. Reducing dimensionality, simplifying complex datasets by removing irrelevant features. Improving model performance, focusing on the most predictive features can lead to better accuracy and generalization. A feature selection technique that uses mutual information to rank features based on their Relevance to a continuous target variable. Predicting house prices, identifying features like location, square footage, and number of bedrooms that have the strongest impact on price. Predicting customer churn, identifying factors like usage patterns, demographics, and customer service interactions that influence churn likelihood. sklearn, features election, mutual infogression. A function in scikit-learn that calculates the mutual information between features in a continuous target variable. Selecting relevant features for building a regression model. Identifying the most informative features for understanding the relationship between a target variable and its predictors. Mutual information is calculated using a formula involving probabilities. It essentially quantifies the reduction in uncertainty about one variable when knowing the other. 1, 2, 5, 2, 3, 7, 3, 4, 9, 4, 5, 11. In this example, we can calculate the mutual information between each feature, feature 1, feature 2 and the target variable. If the mutual information is high, it means that the feature is highly informative about the target. For instance, feature 1 and the target might have a strong positive correlation, indicating that as feature 1 increases, the target also tends to increase.